Good morning, good morning, good morning. All right, today is Tuesday, February 23rd, and for Group B, you will be taking the quiz in class. If you finish early, you'll be able to get started on this. But for Group A, this will be your notes and homework assignment. And it's not terribly long, just lots of practice here with an exit ticket. But today we're talking about solving quadratic formulas. So before, we did a lot of factoring, we did some multiplying, but now we're actually going to find what is the solution. So what I mean by that is we want to get down to a point where it says x equals some number, right? And with a quadratic, typically there are two numbers. All right, so we're going to label that. All right, so let's make some connections here first. In Desmos, I want you to graph this following trinomial. So go ahead and do it on your own first, and then and pause the video, and then I'm going to type it off to the side here as well. Ready? Go. Okay, so hopefully you've done that, and you can kind of see as you zoom in and out what this quadratic looks like. All right, so what does it look like? Well, it kind of looks like a U shape, right? But that U shape is actually called a parabola. I know, kind of a funny word, but parabola. So it's actually called a parabola. I'm sorry, I don't know why I was saying parabola. And the solutions to this graph, right, because there's no intersections on here, not yet at least. At some point we will get to a point where we'll graph two equations at the same time, right, and you'll look at it, and that's called the system, like we did before, and now you'll have a parabola and you'll have a solution there. But for this case, we just have a singular parabola, and it doesn't have any intersections except for at the y, okay, which is the y-intercept, and at the x. Okay, so what are the solutions to this graph? Well, they're actually -6 and 5, and it asks, it says, where are the solutions? The solutions are where it touches the x-axis. Or otherwise known as x-intercepts. Okay, so those are the solutions to a quadratic formula, x squared plus x minus 30. Okay, and in this case, we have two different solutions. We have -6, 0, and 5, 0. Okay, those are our solutions. You can write it that way, or you could write it like this, x equals -6 and 5. Okay, so you can write it as ordered pairs or just the solutions themselves. So that's the actual solution. Those are the two solutions to a quadratic formula, which is weird because remember before we were saying, oh, well, we solved it by saying x plus 6 and x minus 5 and we're done. But as you can see, that is not nearly the same format as this. So what that tells us is that previously we did not actually solve the quadratic. We just factored it down into a spot where we possibly could. Well, now we're going to look at today, making those connections, how to find the solutions to a quadratic formula. So if I wanted to say, like, what are my solutions, I could check it on Desmos by graphing it, right? But you should be able to do it algebraically, okay? So first we're going to factor it, and then we're going to solve it by setting those factors equal to 0. So in this case, if we factor this like we have been in class, it breaks down into x and x, and the factors of -30 that would add up to give me a +1 would be +6 times a -5, right? So this would be +6 minus 5. Okay, so at this point, this is where we would stop before, but those are not the solutions. The solutions are when you break these down and set them equal to 0. Okay, and when you do that, you can solve this simple algebraic expression just by subtracting 6 to the other side. It gives you one solution, and then you add 5 to the other side, and you get the other solution. Okay, now look at this up top. Look at the solutions that we had from the graph. -6, +5, -6, +5. But the factors were +6 and -5. Okay, notice the difference. All right, so what do we learn here? Well, that if you are truly trying to solve it, you can look at what the parentheses are that we factored into, set them equal to 0, and that's something called the zero products property, which basically states that when I have two things multiplied together, like in this case, we had x plus 6, x plus 6 times x minus 5. If either one of, if this equals 0, then we can break it down and say that either this one has to equal 0 or this one has to equal 0, right? So either x plus 6 would be 0. Well, what would make that a true statement? Negative 6 plus 6 would be 0. What would make this one a true statement? Positive 5 minus 5 would equal 0, right? So our solutions are the numbers that would make these parentheses 0 so that it would equal 0 in whole. Okay, so let's go ahead and start just solving some examples here. Then we're going to factor and solve, right? So the first example, we have x plus 9, x minus 4. It's already been factored for us. It wants us to solve it using the zero product property. Cool, so I'm going to break these down. X plus 9 equals 0, and x minus 4 equals 0. So we subtract 9 from both sides. So our solution, if we had these factors, would be x equals negative 9, add 4, x equals 4. Okay? And that's pretty simple. So if you already have the factors and it says solve it, just set them equal to 0. Same thing for number 2. Sometimes you're going to have a messier trinomial. That's okay. We're trying to solve for x. So 2x minus 1 equals 0. 5x plus 4 equals 0. And then just solve the simple equation, just like you've done previously. Divide by 2, divide by 2. So x is 1/2 in this case. And over here, minus 4, 5x equals negative 4. Divide by 5, x equals negative 4 over 5. Okay, so there's our solution there. Okay, so our two solutions would be 1/2 and negative 4/5. Okay, so let's get a little bit more complicated here. We're going to try and factor these down and then solve them, right? So pretty simple. Trinomial here breaks down to x and x. Factors of 7 are 7 times 1, but the middle number has to be negative, so we have negative 7, negative 1. Okay, then we're going to break those down, set them equal to 0. Okay, add 7, so x equals 7. Add 1, so x equals 1. Okay, so there's our solutions. X equals 7 and 1, right? Okay, same thing here. We got two factors. N times n would give me n squared. Factors of negative 12, that would give me a negative 1, or negative 4 times 3. So a negative 4 and a positive 3. To solve, set each of those factors equal to 0. So in this case, when you add 4 to both sides, n is a positive 4. When you subtract 3 from both sides, n equals a negative 3. Okay, so our solutions are 4 and negative 3. Okay, last one here. Oop, this one has a GCF of 7, so we're going to factor that out front. Leaves you with x squared minus 4. Okay, we have 7. And then this is a special case because there's no middle term, and both of these are perfect squares. Remember, 1 and 4. So this would break down to x times x, and a positive 2 and a negative 2. Okay, now this one's a little bit different because you have this number out front, but think about it. If I set this equal to 0 as well, that can't be true, right? Because 7 doesn't equal 0. So 7 is not a solution, but when I bring these down, I do still have two solutions. So subtract 2, so x equals negative 2, and when you add 2 to both sides on this one, x equals a positive 2. Okay, so still two solutions in the quadratic. You might have a GCF out front and you don't do anything with that. Once you're actually solving it, you're just factoring it out, but you should get two solutions. Okay, all right, I want you to go ahead and try these three. All right, so pause the video. Okay, and as soon as you're done, you can check my answers. Same thing at the bottom here. So I'm going to post these and work my way through it so you can see these three. And then for these examples, I'm just going to post the solutions to it on Canvas. And then your assignment tonight is to do the same thing. So you're going to factor all these, and then you're going to solve them. Okay, that's your homework for tonight. All right, so go ahead and pause the video, and you do the 6, 7, and 8. And I'm going to write them out here right now. Okay, so there's your solutions to number 6 if you haven't tried it already. Here's number 7. Because 6 times 4 gives you 24, and 6 plus 4 gives you 10. And as you've probably noticed by now, when you subtract 4 from both sides, when you set it equal to 0, okay, that would give you a negative 4. And on this one, when you set this one equal to 0, you'd subtract 6 from both sides. That gives you a negative 6. Okay. And number 8, they have a GCF. Okay, so let's see, it would have to be a positive 7 and a negative 2. That would give you a negative 14 and a positive 5. And then again, this does not equal 0. So we don't have to worry about that one. But then x plus 7 equals 0. And x minus 2 equals 0. Which means that x would be a negative 7 and a positive 2. Okay? So that's how you do 6, 7, 8. I want you to try 9, 10, 11, 12. I will actually post the key for those. And then you have your exit ticket at the bottom as well. Okay? All right, guys. Let me know if you have any questions. And I'll